Today's organizations face many potential threats against their IT systems and data. In this video, we will talk about the scope of impact. The first thing to do is to look at assets that have value to the organization. Secondly, we then identify threats related to those assets, which allows us to then prioritize those threats so that we know where to focus resources and energy. We then need to determine the business impact or the scope. So if a threat materializes against an asset, does it affect one user? Does it affect an internal user or millions of customers? Is it affecting one computer or an entire network or an entire IT ecosystem? We have to think very carefully about what is being impacted when negative incidents occur. Downtime always has a financial impact because time is money. So whether that is an e-commerce website that's down for a few hours and thus can't sell things to customers on the internet, or if we've got some kind of a payment system that's unavailable, then customers can't buy something, and it ends up being very irritating to customers. And part of what we want to do to retain customers is not irritate them. Recovery time is related to incident response. This has to be done proactively. It has to be planned in terms of an incident response policy so that when these things occur, the appropriate technicians know their roles and know what to do to get systems or data up and running as quickly as possible. Now, in terms of individual components, like for servers and network equipment, we should consider the MTTR, the mean time to recovery. We should also think about the RTO, or recovery time objective, in general when negative incidents occur. The recovery time objective really stipulates the maximum tolerable amount of downtime, let's say for an e-commerce website, before it has a serious negative impact on the organization. The SLA, or Service Level Agreement, is a contractual document between a service provider and a service consumer, and it can be negotiated. Often, it references details such as downtime that is to be expected if it relates to IT services. So let's talk about this in the context of an organization purchasing public cloud provider services. So the public cloud provider SLA to the consumer will have guaranteed uptime. So ideally, we'll have very minimal downtime. There's also items related to response time, not just for IT systems to make sure that they're responsive over the internet to the cloud, but also response time for technical support, when we should expect to get support from the provider. Then, of course, the SLA has a section that deals with consequences. Now, the SLA isn't just about everything being on the back of the provider. Consequences normally turn out to be credits to the consumer, for example, for the next month's usage of cloud services. Pictured here, I've gone into my web browser and popped up the SLA for Microsoft Azure Cloud Computing, specifically for virtual machines. So we can see here that it talks about 99.95% uptime. And as I go through this, I see the sections within the document. So I can see a definition of terms, downtime, service credits that would be applied if Microsoft doesn't meet up to their stipulations inside the SLA, and so on. So there are various types of SLAs. You might even have one within your organization if you're large enough, because departmental chargeback might be used for IT services. When bad things happen to IT systems or data, we have to think about the economic impact. The SLE is the single loss expectancy. This is a value that is derived by taking a look at historical data as well as current data and determining what type of numeric value, monetary value, would be associated with some kind of a negative incident. The ARO, or the arrow, is the annual rate of occurrence that we could expect for a negative incident. So therefore, the ALE is the annual loss expectancy from negative incidences occurring. So the AL is derived by taking the single loss expectancy and multiplying it by the annual rate of occurrence. So this is used to determine if the security controls that we have in place provide a cost benefit. We don't want to pay more for a security control to protect an asset when the asset isn't worth that much, or the likelihood of a failure and then recovering it doesn't at least make sense from a cost perspective. We don't want to pay more for security controls than the asset is worth. The other thing to consider in terms of the impact of negative events is data integrity. If we've got a security breach, then data trustworthiness might go out the window depending on what we've got in place. So we might have audit trails to track activity so that we can trust and rest assured that data hasn't been tampered with or disclosed to unauthorized parties. Then there are hashes and signatures. So, for example, we might use file hashes against a file that results in a unique value, that is the hash. And when we compute that again in the future, if it's different from the original hash, we know something has changed in the file. For example, at the email level, we might look at digital signatures, where the private key, which comes from a PKI certificate, which contains private and public key pairs, the private key is used to generate a unique digital signature, for instance, in a mail message. The recipient verifies the authenticity of that signature by using the related public key. Finally, on critical system processes, we should have failover mechanisms in place. This could be as simple as using failover clustering, where you've got at least two servers offering the same, let's say, line of business application. If one server fails, the other one picks up and users are redirected to the running server. Of course, for that to work effectively, all servers within the cluster should be using the same shared storage so they have the same up-to-date data. But in some cases, you might use data replication across different regions or even to an alternate site. A hot site is another site that we can use for business operations if the primary site fails for some reason. But the reason it's called a hot site is because it's ready to go at a moment's notice. So we've got a facility, it's got equipment, software, it's even got up-to-date data. We don't rely on data backups with a hot site. Now, the way that we have to up-to-date data is by having replication that occurs constantly from the primary site to this alternate hot site. Ideally, it would be synchronous replication, which means when data is written to the primary site at the exact same time, it's also written to the alternate site. If there's a bit of a delay with the replication, then we would call it asynchronous replication. In this video, we discussed the scope of impact,